We are going to look at graphing secant and cosecant. First, I want to remind you that secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. What we're going to be doing is using the patterns that we already know about for sine and cosine to graph secant and cosecant. So if you haven't already watched my graphing sine and cosine video, you probably want to do that first and then come back here. Let's start by looking at y equals secant x. Let's remind ourselves that this would be the same thing as y is 1 over the cosine of x. And let's talk about cosine for a second. Cosine, the pattern is maximum to maximum. The amplitude is 1. And the period is 2 pi. What we're going to do is on our graph, we are going to put in the pieces as if we were graphing cosine instead of secant. If I were graphing this as cosine, I would have a maximum there, a maximum at the end of the period, which is 2 pi, a minimum halfway between, and zeros halfway between those. Then we can mirror that on the other side. Now, let's talk about the fact that this is the reciprocal, that we're not graphing cosine, we are graphing the reciprocal of cosine. So, if at pi over 2, right here, if at pi over 2 the cosine value is 0, we need to look at the reciprocal of 0, which would be 0 flipped over, correct? 0 we can think of as 0 over 1, which means the reciprocal would be 1 over 0, which is undefined. This means that everywhere on my graph of cosine that there's a 0, there will be a vertical asymptote for secant. I'm just going in and putting in those vertical asymptotes. Then the next thing to think about is maximums and minimums. For the maximums of cosine, it would make sense that those are minimums of secants, and the reverse is also true. The minimum of cosine would be maximums of secant. This means we just go in and put in a little, it looks kind of parabolic in shape. I call it a swoopy because that's more fun. And there we have it. Typically, you will only be asked to graph one period of secant, which might be right there in that area. Let's look at cosecant. We're going to do the same type of thing for cosecant, and remember that this would be y equals 1 over the sine of x. Thinking about sine, sine goes from 0 and it goes up first. The amplitude is 1 and the period is 2 pi. I'm going to dot in my sine now as though I were graphing the sine x. Starts at a 0, 0 at the end of its period, 0 halfway between, maximum, minimum. And then again, I can go ahead and do it on the other side here just so I can see the whole thing. Then I will have asymptotes everywhere sine is 0. Trying to draw that in quickly. And then I will have maximums at the minimums and minimums at the maximums. We draw in our, again, I call them swoopies. For any secant or cosecant graph, what we're going to do is pretend that instead of secant or cosecant, it's sine or cosine. put in what our graph would be, and then go back and put in our asymptotes, maximums, and minimums. Here's an example. We are going to pretend that this is y equals 1/2 cosine of 3/2 x. Thinking about all the pieces, cosine first is maximum to maximum. Our amplitude is 1/2. And the period is 2 pi over 3/2, which is 4 pi over 3. Next, what we would need to do is think about our units. My best suggestion would be to make 1 box pi over 3. Then 4 boxes would be 4 pi over 3. Now that I have that in there, let's dot in what this graph would be if it were cosine. Starts up at a maximum, maximum at the end of its period, minimum halfway between, zeros halfway between those. Now, sometimes with secant, we need to go a little bit further, so I'm going to go ahead and follow the pattern and add that next 0. Now, we are ready to put in our asymptotes and then maximums and minimums. There are our asymptotes, and then we'll go in and draw in our swoopies. It's really not necessary to go any further than to have one up and one down, if you see what I mean there. And we don't ever want to draw a part of one. We want to leave that alone. Let's look at the next one. Y equals -2 cosecant 3x. Again, we're going to act as if this is y equals -2 sine 3x, just for our purposes for a second. Sine usually goes a maximum to a minimum there, but because of the negative, we have to flip it, so we know that this looks like that. The amplitude is 2, and the period will be 2 pi over 3. Next, I want to think about my scale. I would suggest we use 2 boxes as pi over 3. Therefore, 4 boxes would be 2 pi over 3. You could make 3 boxes pi over 3 or whatever you wanted to do. Now we are going to dot in what our sine would be if we were graphing sine. Starts at a 0, 0 at the end of its period, 0 halfway between, and then since we flipped it, minimum, maximum. Now we are ready to put in our asymptotes. Remember, those asymptotes occur at the zeros of the sign, and then we will put in our swoopies. Next. Now we have a little bit something different happening here. Let's look at how we would rewrite it. Y equals sine 2x minus pi over 2. Sine starts at a 0 and goes up. The amplitude for this is 1. The period, remember, comes from the coefficient of x. So the period is 2 pi over 2, which is pi. Then remember, right here we have a shift. The shift will be to the right because it's the opposite. And it will be pi over 2 divided by 2, which is pi over 4. So again, we're just kind of pretending that we're graphing sine so we can dot it in and then put the cosecant in over top of it. First thing we need to do is look at our scale. Let's do 2 boxes as pi over 4 so we can see what's happening. So 8 boxes then would be pi. Now we're ready to dot in our sign. First thing we have to do, though, is we need a new y-axis because we moved right, pi over 4. There's my new y-axis. Now I'm ready to dot in sign. Starts at a 0, has a 0 at the end of its period, which is 8 boxes, so I need to go 2 more. Halfway between is another 0. Halfway between a maximum, halfway between a minimum. Now I'm ready to put in my cosecant, which means first I need to put in my asymptotes at the zeros of sign. And then we're ready to put in our swoopies, right? It's just more fun to call them swoopies. One more. Y equals -2 secant x plus pi over 4. The first thing we're going to do is rewrite this as though we are graphing cosine. We know we're not graphing cosine, but this will make things a little bit easier for us to handle. Cosine usually goes maximum to maximum, but we have the negative. That means we have to flip it, which means cosine will be minimum to minimum. The amplitude is 2. The period is 2 pi. There's no coefficient of x there. And this plus pi over 4 tells me there's a shift left pi over 4. The first thing I notice is this graph doesn't really seem to be very conducive to the left, so I'm going to make a couple of adjustments. Hold on just a second. There we go, that's better. I moved my axis over a little bit. Now we need to decide what we want the scale to be on our graph. We are moving left pi over 4 and our period is 2 pi. Let's go ahead and make one box pi over 4. Then 8 boxes would be 2 pi, right? 2, 3, 4 is pi. There's 2 pi. Next, we're ready to graph. So, first thing would be the new y-axis left pi over 4, which is 1 box. Then I'm just dotting in where my cosine graph would go if that were what I was graphing. So on my new y-axis, down 2 is where we will start. We will have another minimum 8 boxes away at the end of the period, which is 2 pi. Halfway between, so 4 boxes, we'll have a maximum. Halfway between there are zeros. And then again, when I'm doing the secant or the cosine, I want to go ahead and do the next 0 there so I can finish it out. Next, we're going to put in our secant graph. So starting with the vertical asymptotes, I put my vertical asymptotes in and then my swoopies. As long as you kind of pretend for a second that you're graphing either cosine or sine, depending on whether you have secant or cosecant, and then dot in what it would be for sine or cosine, then finish out by putting in your asymptotes and your swoopies, you ought to be good.